What's up, guys? My name is Khan, and we're back today with more Logic Car. And for those of you who don't know what this game is, it is basically a polybridge style challenge type game, except we're programming a car. We don't change the level, we don't make any ramps or roads. We have to program the car to work within the level and accomplish the task. It's a really, really cool game. I really like it. So we're on level 15, or I guess we've beaten level 15. Not sure what that means. I think we're on level 16. Yep, 16. And in this level, we have to do some things. So the game basically allows our car to do all sorts of fun stuff, including carrying this box right here. And also we have to grab trophies, and we have to bring trophies to the blue flag at the finish. That's sort of the objective. Take the car, get the trophy, flag at the finish. Now, in every level, we don't always necessarily get the same things. For example, in this level, we have our engine, which is fine. We've got an air burster, which lets our car jump. Okay, I don't know if we're gonna need that. We've got an angle sensor, and we've got a obstacle sensor, and we've got a picker, and we've got a launcher. So I think what we gotta do is launch this box to hit that off, and then pick up the next thing. So I think what we can do is just start the engine right away. That's pretty standard. And then we can also have the picker trigger, I think, right away. I'm pretty sure you can have the picker trigger all the time, and that's fine. We're gonna delete the air burst, so we don't need that. And then all we gotta do is compare the angle sensor to a value, you know, and say like, whatever, greater than 0. Let's do greater than, like, I don't know, 5 degrees, something like that. And that, of course, will trigger our while loop, which is this branch node nonsense. True to fire the launcher. False, it fires itself. And, of course, we program this in. So in the last couple of videos, I've done 2 videos on this game already. It's kind of, obvious, I guess. It's a node-based programming system. The programming starts at the start, goes along these red lines, and then as it hits certain areas, it pulls conditions. So it'll pull the true, false conditions or stuff like that. So I think this will work, unless I've totally forgotten how to play this game. Here we go. Oh my god, why did that yeet it? Okay, so I think the problem is, when the car lands, we can actually log to see what it's doing. We can log the angle sensor and then click on the car. But I think when it lands, yeah, see, the angle goes to 5.17, so it's too high because the suspension flexes. So that's not a big deal. We can just set this to like 10 instead. And that way it'll only trigger when it goes down the hill. Oh, okay, I guess it's a negative. Less than -5. There we go. Go down the hill. Oh, that was too much. But we can fix this. We can change the power of the launcher. Just reduce that and see if we can get it perfectly timed here. That was pathetic. Well, it picks it up right away, so that's good. Watch it be too much at the one little bit and not enough. That should be just it, right? All right. Oh! The car is too fast. Uh-oh. I didn't think that. We might have to stop the car. How are we gonna stop the car? What if I give this just a little bit more launcher power? Can it, like, hit that trophy off a little bit harder? That was pathetic. Okay, let's change the angle. Let's try -10. Make sure it goes down the hill a little bit more. Oh, that was so close. Okay, hold on. See, if we can get this angle just perfect, but I don't think we have to change the car at all. We'll hit the trophy harder. There we go. Catch it. All right, you're a champ. You're a champ. Awesome, that was sick. That was amazing. The only other way I could think of doing it is we'd have to have the car, like, quite literally stop its engine. That worked perfect, though. I'm gonna assume on this one, the big red button lowers the drawbridge. That would be my guess. Okay, so we probably have to drive forward until we see this box, and then drive in reverse to jam this box onto there, and then drive forward again? Like, what if we just do... this is gonna be a tough one. All right, so we got the engine set up. We're gonna have to change the engine mode, so we're gonna have to feed it a number, and then reevaluate it over and over again. So this is actually, I think we do this, and then I think we just reevaluate the engine over and over again. So every time it flows through, it'll recheck it. And then we just need to change the mode value based on an obstacle sensor, I think. What do we got here? Burster? How is that gonna help? What if I just, this might actually, I might need this later. I got an idea for that. Okay, so obstacle sensor forward. I need you to go in reverse first. And then I need you to turn around and go forward. So we're gonna need this 2 number nonsense and this comparison operator. So if the forward obstacle sensor is greater than like 50, then that'll feed to here. And if the value's true, give it a 1. And if the value's false, give it a -1. But that's not gonna, see, this is gonna, watch, this is gonna basically, we'll log this so we can see what this does. But basically what it's gonna do is it's gonna start going in reverse until it's 50 blocks away, and then it'll go forward, and then it'll keep going reverse if this keeps triggering, I would imagine. Yeah, okay. That's great. Yeah, it's still not, it's 48.78, but wow, okay, so let's set this to 40. And then we'll see what happens, but I have a feeling it's gonna catch this box, which is fine. And then it's gonna go forward. See, it's gonna do this nonsense. So I think there's a solution here. I think we manually set 2 engines. We have an engine mode 1 and engine mode 2, and we could use the obstacle sensor, and we use that against just a couple of while loops. Not this. This might not be an efficient way to do it, but I think we can do this. We use like branch nodes basically, right? And we just have this one go like this, and then true. If false, it loops back around and reevaluates. And this one, engine flashes forward, true. If false, it reevaluates. And then what we're gonna do on the first one is we're gonna evaluate the backwards sensor. And if it's greater than 0, which means it sees something, then you can progress forward and go in reverse. So we're gonna wait until that box drops, this box here. It's gonna drop down, and then we're gonna go in reverse because this will be greater than 0. The obstacle sensor will not pick up the terrain. This is actually cool that this menu exists. That's kind of neat. See, I'll show you. See, has mass, has friction, has bounce notes, is obstacle, is not obstacle, but is ropeable. We don't have ropes yet, which is interesting. So that's that. That'll be that side, and then we'll do another obstacle sensor here. And wait, hold on. We go negative. Yeah, and we go backwards until the forward obstacle sensor is greater than the distance of 40 or whatever. And then that way, once we see forward, then it'll turn around and trigger this next node. So theoretically, this should work, right? We're sitting on this loop until we see the box drop, and then we'll go in reverse, and then we'll pass forward to this loop, and then we'll sit on this loop until we're so far back that we are away from this obstacle, and then, you know, we'll go forward. Everything will be peachy. We just wait, sees that, pushes it in reverse, goes forward, full speed, and it should never turn off. Perfect. That was awesome. That's not exactly the best way to do it. See, you could do this passing the engine mode value, and you do 2 comparisons and then switch. So it'd be like, if this is true, then do one thing, and then if this is also true, like you could write a formula for it, but this is just a much simpler way to do it, to be honest. And it works perfect every time. Look at that. Goes in reverse, full speed ahead. That's awesome. Completed. Next. To be honest, I'm really excited to get into the ropes. What the holy... You gotta be kidding. This is an obstacle, right? That's gotta be an obstacle. Okay, hold on. First off, we have 2 canvases, which means we can program 2 different sets of things, but we have 3 cars. What happens if I press play? Obviously nothing moves. Those 2 barrels float. Okay, so obviously this guy has to full send it to there, right? And this guy has to full send it to there. And then somehow in the time that he puts down the button, this guy has to full send it. I feel like that's the issue. So hold on, let me see what happens here. Everybody's on canvas 1 by default, right? If we go here, canvas 1, canvas 1, canvas 1. All right, let's just do something. Let's do something really, really stupid. I'm gonna assume we have a burster. We have nitro. Perfect. Need nitro. Air burster especially. All right. Engine triggered. Nitro triggered. All right. What does that do? What does that do? Oh, you guys hit each other. Well, you guys are big stupid. Okay. We just need these on a delay. That's easy enough. Canvas, we'll put you on canvas 2. And canvas 2, We'll just do start, and we'll put an obstacle sensor. And as long as the obstacle sensor A is, you know, less than 0, then it can trigger. And the reason why this works is the car is an obstacle, so it should see the car in front of it, which means it won't move until this car's out of the way, which means the car's like down here somewhere, and then that means that one will be able to go. So this should be fine, and then we'll do the same thing, engine and nitro. The other car, we're gonna have to put an even longer delay on, but we only have 2 canvases, so I don't know how that one's gonna work. We'll have to see what this does anyway. Let's see what this does in the get-go. So this one's gonna go, that one's gonna die. That one makes it. What do you see? Oh my god, you see that brick at the very end? Okay, so we have to, hold on, we can fix that. Let's make you canvas 2, and you canvas 1. So the right one will go first, this one will go second, and you know what, you can be canvas 2 too. Let's see what happens if you go second. You go first. Perfect. Oh, that just triggers. What do you see? You see something behind. It doesn't matter. You should, oh, I didn't loop it. I'm big dumb. Big dumb. Need the false loop. There we go. I was like, why is it not doing it? There we go. You go forward. You go reverse. Oh, this worked perfect. It was easy. Look at that. That was awesome. That was actually amazing. I can't believe I didn't loop that. See, sometimes I feel like they give you these tasks, and if you just think about them, like, slowly, they're a lot easier than they appear. At first, it looks really difficult with all the, like, the barrels and stuff, and all the extra, like, pieces, and oh my god, what is this nonsense? Are you serious? How many canvases do I... 1 canvas. Are you actually for real right now? I don't understand. There's 5 flags. There's only 4. There's only 4 cars. What the heck is the green thing? What is that? They just don't even explain it. What is the green? Well, I don't understand. Yeah, I have a burster and an obstacle sensor. Okay. Oh my god, we're gonna have to burst them in different directions depending on what they see. Okay. So if you see a car below you, you can go forward. If you see a car behind you, you go forward. Now to get these 2 to these flags. This one could just also burst forward, and this one has to burst backwards. Which means if you don't see a car in any direction, burst backwards, otherwise burst forwards. That's basically what that means. So we need like 4 comparisons to all 4 directions. And then these 3 will burst forward, and that one will burst back. But I don't understand what the green... you know, let's try that to start. So comparison. Forward's greater than 0. Or... this is going to be so bulky, it's ridiculous. But anyway, alright, here we go. Forward's greater than 0, or backwards is greater than 0. Or, you know, downwards is greater than 0. Or upwards is greater than 0, right? Like, any one of those 4 is a valid... Do I need down... yeah, I need downwards. Well, no, forward and backward handles these 2. So I just need upwards for this one. So upward greater than 0. Right? So if any one of those 3 conditions is true, then that means there's another car. And this one's the only one that bursts back. So all of them burst forwards, and then this one bursts backwards. So now... okay, how do I... was there an OR gate somewhere? Where's this... no, that's a branch node. Logical. True and true. Perfect. Make that OR. And another logical as well. You, and you. And that's another OR. Alright, so start. And then we need just basically just a branch node. Right, so start triggers the branch node. The branch node evaluates all these conditions instantly. If it's in any direction, it'll burst forward. And if it's not in any direction, it'll burst reverse. So they all should burst right away at the very start. I did them all in the wrong direction. Okay, hold on. Forward is actually backwards, and backwards is actually forwards. It's the direction of the burster, not the direction you want the car to go in. Here we go. What's 12 mean? Wait, what? Did I use too many logic components? Is that what the 12 means? How many nodes am I allowed to use? Well, the other option is we can add the forward, back, and third, like all three sensors together. And if they're greater than 0 added together, that might be less nodes. Obstacle sensor, add, right? Like if I do this, forward plus backwards, and then add you guys to the upwards, like that covers all three as well. And then I have to compare this and say if that's greater than 0, then burst forward. I don't know if this is less nodes. This looks like less nodes. Is it gonna let me do this? I'm still very confused about how this like whole thing works, to be honest, what it actually wants me to do. Like what is this? 8 is a cut. Okay, 8's good. I got these backwards again, of course. Backwards and forwards. There we go. Okay. So it doesn't care which flag you go to. It'd be nice if they gave me a total, like 8 out of what? You know, my last one was like, what, 11 or something? And that was too much? Pretty cool, though. Pretty simple solution. Alright. So... Okay. What? How the heck? Okay, we have 2 canvases. Now, the thing with the treasure chests is you have to bring them to the location. You can't, like, you have to grab the chest with a car and then bring it to the spot. Well, what happens, hold on, if I just do this, I have a feeling this is just gonna work. If I go start, right, and I just take the canvas 1, let's do this super simple. Canvas 1 is gonna be the left car, canvas 2, we're gonna make you the right car. Because we have 2 canvases. I think the left car easily just has to start in reverse and pick up the thing. And it'll push both, but it'll disappear when it hits the flag. And then we should be fine. That's obstacle sensor. Where's the picker? Picker. There we go. You just literally just pick this up. So I think, watch, if we do this, it's gonna pick that up. And it's slow, but it doesn't matter. Oh, it purges that one. Okay, that's not bad. That's actually okay. And then we just need this guy to hit the NOS, land on this button, and then this guy, when it does, oh, this is easy. Okay, this is actually really easy. Engine mode 1, sure. Picker, sure, it goes reverse, whatever, that's fine. And then we can have it change engine modes when the backwards obstacle sensor no longer senses something. Backwards obstacle sensor, less than 0, right? Flip engine modes to engine 1. We could actually do this smarter. Let's do this proper. So we turn the picker on right away. We go to engine, right? And then we have this as a, what is it, true to false? No, true false to number. There we go. So value, and when true, the value is 1, and when false, the value is 0. So when it's less than 0, we want it to be a -1. No, we want it to be 1. Yeah, it goes reverse first. So this should be perfect. It'll start with the engine in reverse, and then when the value is less than 0, which means it doesn't see an obstacle behind it, it activates as true, and it'll set it to 1. Yeah, no, this works. It's smart. So this one will go, pushes this back. You're dumb. I need to reevaluate the engine loop over and over again. There we go. All right, reverse. And then it goes forward. Perfect. All right, and then in that time, this guy, canvas 2, has to go full speed, boost over this, and land on the button somehow. So canvas 2, we're gonna start. First thing we're gonna do is start the engine, because we need to open up this so that the second one, the car falls back into that area. And I think we're gonna hit the nitro right away. And is this brakes? Oh. I mean, that's cool, I guess. If you want to be a loser and use brakes. All right. You know, that actually wasn't bad. I think if we do a forward burst or reverse burst, this might help. Might have to use the obstacle sensor and sense when it sees one of these, but let's see what this does first. Oh yeah, that helped. Perfect. Easy. Amazing. Holy cow. Did you see that? The speed that car got. Look at that. Look at that acceleration. Just gone. lands on the button. It seems like the button, too, you don't have to hold it. You just have to activate it once. That's awesome. Perfect. All right, so I think this is the last level we're going to do. This is probably the most polybridge out of any of the levels. Do we have 2 canvases? 2 canvases. Okay, so top car will be canvas 1, bottom car will be canvas 2. Seems like we need the bottom car to jump first and activate the bridge. What do we got for controls? Let's do 2 first. So 2 starts. We've got engine and nitro. What is this? Send message. Yes, let's go. Oh my god, that's awesome. Oh, that's so awesome. Okay. And that's an obstacle, isn't it? That's a tree trunk. That is a tree trunk. Okay. So when this car sees an obstacle in front of it within a certain distance, right before it hits the flag, it's got to send a message for that car to start moving. That's the key. This is actually really, really cool. So obstacle sensor, we're going to put that to a while loop. So we're going to start with the engine right away, hit the nitro right away. That should get us over the nonsense. Hit a branch node. The branch node true sends message. Message value will be 1. Because then we can actually use this message as the engine power. I don't know. We'll find out. And we're going to compare the obstacle sensor, of course. So forward obstacle sensor, if it is less than 10, right, then we can pass through the branch loop. We'll remember to do that. And I think canvas 1, we could do this right away as well. Start, receive message, and then engine power. And I think we just do this engine mode, loop it back to itself, and evaluate with the, oh, hold on. Okay, hold on. Do I have to receive message first, maybe, and then connect this? I don't know if that's gonna work. Might have to loop the receive message as well. Let's see what this does. The bottom one goes, nitro, makes the jump. Oh, that one has a thing too. I don't know if it received the message though. Let's log this, I guess, and see what it does. Result true. A is negative. Oh, because it didn't. It sends the message right away in the beginning and doesn't see anything. Poop. It won't work because there's no obstacles. What do we have? This is an obstacle, but it can't see that. Oh, it just needs to check if there's an obstacle in front. And okay, this is actually easy. Let's not do this as the node. Let's just do an obstacle sensor and an obstacle sensor here. And if both of these are greater than 0, right? So if the backwards one is greater than 0 and the front one's greater than 0, then it can see both the log and the rock, right? It'll see the rock and the log simultaneously when it's here, and then that way it triggers it and we're all good to go. So we just do those two, and then we gotta do a logical majumner, so both of these are true, then we pass that forward, and that sends a message, right? So that should do that portion. Let's see if this thing receives a message. -1. Okay, still receives -1. Send message 1. Do I need to loop this to itself? Probably, right? Let me log that and see what it says. Send message 37 times. Receive message -1. Yeah, because it only checks it once. And now it got it. Interesting. And then once it checks it, so okay, hold on. We actually have to use, oh my god, this is actually really complicated. Okay, so when the message is greater than 0, then it's received the message, and then we can pass it through the functional while loop. So we have a while loop here that's just evaluating itself, right, until the message is received. And then when the message is received, then we can pass forward to the engine node. And I keep calling these while loops. They're called branch nodes. But if you were like thinking about it in terms of programming language, it's really a while loop. You're waiting until a condition is completed before you execute the next line of code, which is the engine. So this is actually, that should be perfect. Watch this. This is going to go. This is going to receive the message. What? Oh, I'm wrong. The branch node, I got to go back more. Hold on. Branch node, check condition. If the condition is true, go there. If the condition is false, go back and check the message again. There we go. It's got to loop all the way back. So we got to keep looping through and checking this comparison. That makes sense. Because in that one, all those error messages were basically, it wasn't reevaluating. There we go. Oh my god, you barely did it. Let's go. That's so cool. I love, man, this game is sick. There's so many cool things in this game. It really makes the puzzles fun. Especially with this multiple canvas remote control nonsense. But here we go. So we program this car to raise the bridge for this car. We can actually, like, I'm gonna watch them from a programming side. So this one does nothing. And then when it sees both, it sends the message. That's so good. Oh, I love that. I'm gonna watch that now again. That's great. This car, radio controls that car. And it's like perfect timing with the bridge. That's actually awesome. Well, let me know what you guys think in the comments down below. Let's check out the next stage. See what it is all about. Oh my god, this looks actually kind of terrible. This is literally, this has to push the button and then the bridge is gonna move. And then this has to let go of the button and grab this and jump across with the bridge. Oh my god, this is gonna be an amazing challenge. Well, let me know what you guys think of this series in the comments down below. Level 22 of 55, not bad. We still have some work to go, but all in all, I really enjoy this game. Every time I play a new level, it gets more and more exciting. And you can tell that they're like kind of teaching you individual concepts in each level. And then eventually it's going to get really, really gnarly towards the end, I can imagine. But I'm definitely going to beat this game, 55 levels. There's a bunch of games I haven't ever like beaten before. Pretty much like I never beat any games on my YouTube channel. So I'm going to beat this game for once. But yeah, let me know what you guys think in the comments down below. If you have other cool games like this to suggest for when this is done, let me know in the comments down below. And as always, I hope you guys enjoyed this video, and we'll see y'all next time.